Hello and good afternoon, everybody, and welcome to What Do We Know, a podcast dedicated to education through discussion. I'd like to thank everyone, of course, for joining us today on this wonderful Sunday as we take a look at climate change. Climate change has become a charged subject with a lot of attention in news and a variety of stances, some educated, some not, but many alarmingly purely political rather than dealing with any facts at all. So, as Top is over there yelling that he is currently live. What do we know, sir?
Oh, what we know is I'm off track. And for some reason, when I looked at your card, I thought Akia was my guest host today. All right. So let's see here. We're going to start off with history. So history of climate change goes back pretty far, farther than most people really know. What is the crinkliness going on over here?
It's almost like every Sunday we do the same thing.
It does seem like, yeah. All right.
Hey, so, Phoenix. How's it going, Evo?
The history of things is it starts with the Greeks. The Greeks really began the formal study of climate. In fact, the word climate is derived from the Greek word klima, meaning slope, referring to the slope or inclination of the Earth's axis.
So the world's not flat.
No. It's not. We literally have pictures. You can send up a $15 weather balloon yourself with a GoPro on it and see the goddamn curvature of the Earth. Those people are idiots. The first distinct climate treaties were the works of Hippocrates, who wrote Airs, Water, and Places in 400 BCE. And then we also had the Chinese scientist Shen Kuo. That lived from 1031 to 1095. Pretty sure that's probably 80, inferred that climates naturally shifted over an enormous span of time after observing petrified bamboos that were found underground near Jiangsu, modern-day Yan'an, Shanxi province, a dry climate area that's completely unsuitable for the growth of bamboo. So at some point they were able to figure out, all right, this must have grown here at some point because it cannot grow here now. Makes perfect sense. And then early climate researchers include Edmund Halley, who published a map of the trade winds in 1686 after a voyage to the southern hemisphere. Benjamin Franklin in 1706, who lived 1706 to 1790, first mapped the course of the Gulf Stream for use in sending mail from the United States to Europe. And Francis Galton, from 1822 to 1911, invented the term anticyclone. Helmut Landsberg from 1906 to 1985 fostered the use of statistical analysis in climatology, which led to its evolution as an actual physical science that we study today.
Man, you were using a lot of terms right there, Top, and I think it's about time we dive into some of those and figure out what some of this terminology actually means. What do you think about that?
Words are important.
We screw them up all the time, so we would know. Climate change occurs when changes in Earth's climate system result in new weather patterns that last for at least a few decades and maybe for millions of years. The climate system is comprised of 5 interacting parts: the atmosphere, which is the air; the hydrosphere, which is the water; the cryosphere, ice and permafrost; the biosphere, living things, like this is our biosphere; and the lithosphere, which is the Earth's crust and upper mantle.
Visible and Twisted's picture card.
Right there. You're damn right. That's kind of why I threw it up there. I figured it was fitting. Not to be confused with the pizza crust, although very delicious. The climate system receives nearly all of its energy from the sun, with a relatively tiny amount from Earth's interior. The climate system also gives off energy to outer space. The balance of incoming and outgoing energy and the passage of the energy through the climate system determines Earth's energy budget. Now, when the incoming energy is greater than the outgoing energy, Earth's energy budget is positive and the climate system is warming. If more energy goes out, the energy budget is negative and the Earth experiences cooling. So a good example of the warming would be anytime Top goes on a long rant. That would be an example of a lot of hot air and warming.
Or if I have too much sugar.
Yes. Now, as this energy moves through Earth's climate system, it creates Earth's weather. And long-term averages of weathers are called climate. So changes in a long-term average are called climate change. Such changes can be the result of internal variability when natural processes inherent to the various parts of the climate system alter Earth's energy budget. Examples include cyclical ocean patterns, such as the well-known El Nino Southern Oscillation, and less familiar Pacific Decadal Oscillation?
Decadal.
And the Atlantic Multi-Decadal Oscillation. Climate change can also result from external forcing when events outside of the climate system's five parts nonetheless produce changes within the system. Examples include changes in solar output and volcanoes, essentially, volcanism or Hawaii.
Hawaii's to blame.
Yes,
Oh,
that's you, IKEA. It's all on you. He said, so a loss would be me sitting in front of a heater trying to warm my cold heart. That would definitely be a loss.
There you go. All right, and then global warming is a long-term rise in the average temperature of the Earth's climate system. In the modern context, the terms global warming and climate change are commonly used interchangeably, but climate change includes both global warming and its effects, such as changes in precipitation and impacts the region.
That's still you, buddy.
I know, I thought I accidentally the words. I was double checking. Yeah, basically, global warming. It's kind of all out of favor because global warming and global cooling are both part of climate change, and global
Right.
warming leads to a lot of those silly ass
And the whole
jokes that we always hear.
global warming thing confused so many people, and that's where you get the a lot of the people that try to use that
Yes.
argument. Well, if it's global
It's snowing
warming,
outside.
yeah, it's
Oh.
snowing outside. Oh God.
Exactly. So then, climatology itself incorporates many disparate fields of research. For ancient periods of climate change, researchers rely on evidence preserved in climate proxies such as ice cores, ancient tree rings, geologic records of changes in sea level, and also glacial geology. Physical evidence of current climate change covers many dependent lines of evidence, a few of which temperature records, the disappearance of ice, and extreme weather events.
Now, there's a lot of data in support of the human cause as well. It is the Earth's atmosphere that makes most life possible. To understand this, we can look at the moon. On the surface, the moon's temperature during daytime can reach, and this blew my mind, 212 degrees Fahrenheit. At night, it can, and for those of you who deal in,
Lesser units.
Yes, lesser units. That's 100 degrees Celsius. At night, it can plunge to minus 173 degrees Celsius or negative 279.4 degrees Fahrenheit. Now, I don't know about you, but my nipples are going to be falling off with that one.
Yeah, I understand now why those spacesuits were so damn thick.
Yeah, a little bit. In comparison, the coldest temperature on Earth was recorded in Antarctica, which was a warm in comparison, negative 89.2 degrees Celsius, which is a negative 128.6 degrees Fahrenheit. According to the WMO, the hottest was about 57 degrees Celsius, which is about 134 degrees Fahrenheit, measured on July 10th of 1913 at Greenland Ranch, which is in Death Valley. So if you ever wanted to know probably why it's called Death Valley, it's probably a good reasoning there. Man could not survive in the temperatures on the moon. Even if there was air to breathe, humans, plants, and animals can't tolerate the extremes of temperatures on Earth unless they evolve special ways to deal with the heat or the cold. Nearly all life on Earth lives in areas that are more hospitable, where temperatures are far less extreme. Yet the Earth and the moon are virtually the same distance from the sun. So why do we experience much less heat and cold than the moon? And the answer to that really is because of our atmosphere. The moon doesn't have one, so it's exposed to the full strength of energy coming from the sun. At night, temperatures plunge because there's no atmosphere to keep the heat in as there is on Earth. So think of it like a blanket, or actually a better way to think about it is if anybody lives in those climates where it does get cold or hot, you have those like thermal curtains. Essentially, during the summer months, they help keep the cooler temperatures in and everything where it's not getting too hot. And then it, during the winter, keeps it warmer. So it kind of works similar to that. Hold on. I think he just experienced a blue screen in his brain.
Well, the wife was doing something. Move.
Oh.
Move. Sorry, every time my part comes up, things happen.
No, climatology is not like Scientology, IKEA. Climatology is actually a real thing.
So the laws of, and this part I was really kind of, I put this in here, but I don't understand it. The laws of physics tell us without the atmosphere, the Earth would be approximately 33 degrees Celsius cooler, or 59.4 degrees Fahrenheit cooler than it is. But the temperature difference between us and the moon is more than that. So I'm not really sure where they got those numbers. But but at least the study that I read on this. But basically, they're trying to say that the Earth would be significantly cooler and I guess also warmer on the time of day than it would be without the atmosphere. It would make the surface uninhabitable for humans. Agriculture, as we know it, would more or less impossible if the average temperature was negative 18 degrees Celsius. In other words, it'd be freezing cold even at the height of summer. So you couldn't grow crops, couldn't have food. The reason the Earth is warm enough to sustain life is because of greenhouse gases in the atmosphere. These gases act like a blanket, keeping the Earth warm by preventing some of the sun's energy being re radiated out to space. This effect is exactly the same as wrapping yourself in an actual blanket. It reduces heat loss from your body and keeps you warm. If we add more greenhouse gases to the atmosphere, the effect is like wrapping yourself in a thicker blanket, even less heat is lost. So, how can we tell what effect CO2 is having on temperatures and if the increase in the atmospheric CO2 is warm?
And it actually is one particular method of measuring the effect of CO2 is by using satellites to compare how much energy is arriving from the sun and how much is leaving the Earth. What scientists have seen over the last few decades is a gradual decrease in the amount of energy being re-radiated back into space. In the same period, the amount of energy arriving from the sun has not changed very much at all. This is the first piece of evidence. More energy is remaining in the atmosphere. Now, what can keep the energy in the atmosphere? The answer is, like he mentioned before, greenhouse gases. Science has known about the effect of certain gases for over a century. They capture energy and then emit it in random directions. The primary greenhouse gases, carbon dioxide, CO2, methane, CH4, water vapor, nitrous oxide, and ozone, comprise of around 1% of the air. This tiny amount has a very powerful effect, though, keeping the planet about 60 degrees warmer than it would be without them. I'm thinking there might be a math error there, or maybe it is something there's not 100% understanding with that, because, if there's no atmosphere and you compare it to the moon, so I'm not quite sure.
Yeah, I don't know where they got the math
with
on that,
that.
but I couldn't find it in it.
And again, I want to point out this is exactly why everyone should do their own research, because there's going to be information that we're going to get that may not be 100% accurate. So I always encourage everybody to always look up what we're talking about. It's definitely an important thing to do to make sure you do have all the information. Anyways, the main components of the atmosphere, nitrogen and oxygen, are not greenhouse gases because they are virtually unaffected by long wave or infrared radiation. This is the second piece of evidence, a provable mechanism by which energy can be trapped in the atmosphere.
For our next piece of evidence, we must look at the amount of CO2 in the air. We know from the bubbles of air trapped in ice cores that before the Industrial Revolution, the amount of CO2 in the air was approximately 280 parts per million. In June of 2013, the NOAA, the NOAA Earth System Research Laboratory in Hawaii, announced that for the first time in thousands of years, the amount of CO2 in the air had gone up to 400 parts per million. That information gives us the next piece of evidence that CO2 increased by nearly 43% in the last 150 years. Now, I've got some charts that can be popping up randomly on the screen here, and these are with this study that I found that will be able to kind of show what they're talking about here. And you can see on this particular chart here, the atmospheric and total CO2 kind of all are sloping up at the same time between about the late 1800s into the 2000s. The final piece of evidence, the quote smoking gun, the proof that CO2 is causing the increase in temperature. CO2 traps energy at a very specific wavelength, while other greenhouse gases trap different wavelengths. In physics, these wavelengths can be measured using a technique called spectroscopy, and this is an example in our second chart. This is a difficult chart to read because it's not really a progressive chart. It's you're looking at a beam of light and seeing the amounts in that beam. So it's not a
Right.
get high, go low. It's just what in this spot of air has the most. So CO2 there is on the far left, and everything else is kind of with it. All of these together make up that 1% of the atmosphere. So when you're talking that CO2 is increased, it's increasing probably about 0.3 or maybe some fraction of that 1%. They weren't clear on what portion of it it was. But that's where this is the only scientific evidence I could find. Everything else was just kind of discussing that it's been proven, but this is the only thing I found that could prove it and show, okay, CO2 is a bigger part of those greenhouse gases. But I'm not a scientist, so this is a picture.
Yes.
I don't know exactly how to read it.
And we're going to try and break it down as best as we possibly can. So the graph is showing different wavelengths of energy measured at the Earth's surface. Among the spikes, you can see energy being radiated back to Earth by ozone, O3, methane, CH4, and nitrous oxide, N2O. Or is that N20? I think it's N20.
N20.
N20, yeah. But the spike for CO2 on the left dwarfs all the other greenhouse gases and tells us something very important. Most of the energy being trapped in the atmosphere corresponds exactly to the wavelength of energy captured by CO2. Now, this next section I'm going to read is verbatim from the article that we pulled it from. So we did not phrase any of it this way. So I want you to take that into consideration. Like a detective story, first you need a victim. In this case, the planet Earth. Victim blaming. More energy is remaining in the atmosphere. Then you need a method and ask how the energy could be made to remain. For that, you need a provable mechanism by which energy can be trapped in the atmosphere, and greenhouse gases provides that mechanism. Next, you need a motive. Why has this happened? Because CO2 has increased by nearly 50% in the last 150 years, and the increase is from burning fossil fuels. And finally, the quote smoking gun. I added that little quote bit, by the way. The evidence that proves who done it. Energy being who wrote this?
I know, that's why I prefaced it. Like, really?
Yeah, energy being trapped in the atmosphere corresponds exactly to the wavelengths of energy captured by CO2. The last point is what places CO2 at the scene of the crime. The investigation by science builds up empirical evidence that, quote, proves, end quote, step by step that man-made carbon dioxide is causing the Earth to warm up.
Yeah, I have my issues with that. The articles I was able to find on this, like the one thing that didn't get covered in this article in this half is they mentioned that it went up by 50%, and I can see their proof of that. But they just say it's because of burning fossil fuels. They don't give any backup as to where they see the increase and where, because you can't just say the Industrial Revolution started the burning fossil fuels and therefore, because China lagged way behind us on
Right.
the Industrial Revolution. So theirs happened at a different time than ours. Other parts of the world didn't have it at the same time we did. So I really tried to find more scientific fact on that piece of it, but there's like nothing. Nothing that I could find anyway, not the places that I was looking. But it brings us to the next part of this discussion, which this chart's kind of the mother of all charts. It's big and it's kind of scary, but it's going to be referenced to this whole next section. And I found a really, really good article that was against the human driver of climate change. And until late 2006, global temperatures were more than a degree Fahrenheit warmer when compared to the 20th century average. From August of '07 through February of '08, the Earth's mean temperature dropped to near the 20th century average of 57 degrees. And then since that time, land and ocean readings have rebounded to the highest levels in recorded history in 2016, with a temperature of 58.69 degrees Fahrenheit for 2017. The global temperature then dropped a little bit to 58.51 degrees Fahrenheit. So when you look at this crazy chart, that last orange spike is the height of temperature in modern times. It's hottest it's been since recorded history was really available. But as you can see from everything else, we've had a lot of hot, cold periods, and it was actually much warmer back around 1100 BC, around the same time the Hebrews were leaving Egypt. High five, Twisted.
Hey!
So you had human beings being around when it was much warmer than it was now, and there was not any large industry. So there is some comparative data, and this goes all the way back to 2400 BC, I think, is the farthest back it goes in this chart. We're going to come in
Yes. Just a little bit beyond 2400. I want to say probably closer to like 2500 BC.
Yeah, I think the ice cores only, or the cores they drill for can only go back so far because
Right.
it's so deep. But the people that made this particular chart, the creators, stated the following quote: "We climatologist Cliff Harris and meteorologist Randy Mann believe in rather frequent climate changes."
Sorry, that name.
What did I miss?
The
Oh
name.
yeah, Randy Mann.
Yeah.
The porno parody is just waiting for this.
Oh, yeah.
We believe in rather frequent climate changes in our global weather patterns. Geologic evidence shows our climate has been changing over millions of years. The warming and cooling of global temperatures are likely the result of long term climatic cycles, solar activity, sea surface temperature patterns, and more. However, mankind's
Here I
activities of the
come.
burning of fossil fuels, massive deforestations, and the replacing grassy surfaces with asphalt and concrete, which is known as the quote, urban heat island effect, are likely creating more harmful pollution. Yes, we do believe we should be going green whenever and wherever possible. So they just don't believe it's directly affecting the climate overall, but they do believe let's not screw up the planet because
I
it's the
mean,
only one we've got.
yeah, exactly. I want to take a moment to thank Tall Yet Small for the follow. Thank you very much for that. We appreciate the support. Moving right along, our planet seems to be in a cycle of constant change. According to an article by the National Oceanic and Atmospheric Administration, which is the NOAA, or the NOAA that he was talking about before, on climate.gov, in August 2014, our planet likely experienced its hottest weather, millions of years ago. One period, which is probably the warmest, was during the Neoproterozoic.
Sure.
Proterozoic,
I'm going to go with that.
around 600 to 800 million years ago. Approximately 56 million years ago, our planet was in the
Paleocene, Eocene.
Oh, yeah. I wasn't going to get that one. Thermal maximum, as global mean temperatures were estimated as high as 73 degrees Fahrenheit, over 15 degrees above current levels. By contrast, evidence shows there have been at least 5 major ice ages on planet Earth. One of the most well-documented and largest occurred from 850 to 630 million years ago, is called the Cryogenian period.
Yes, Cryogenian.
Glacial ice sheets likely reached all the way around the equator, producing a snowball Earth. Scientists believe that this massive ice age ended due to increased underground volcanic activity and perhaps a much warmer solar cycle. One reason scientists believe that the Earth's temperature reached a record level in 2016 was the very strong El Nino in the waters of the South Central Pacific Ocean that formed in 2015. El Nino is the abnormal warming of ocean waters that often leads warmer air temperatures and less snowfall during the winter seasons.
Right, and
so that could
was all over when it happened.
Right, and I know for a lot of people, I think even now it's correct me if I'm wrong here, Top, but like this year, we've had a slightly longer, I guess, summer in a way. It's been warmer during the winter than usual, but then the winter hit really hard. Like, there's been some odd weather changes, odd weather patterns that have definitely taken place that aren't usual over recorded, span of time.
Yeah, all the different factors will make the weather do different things, and we're going to kind of get into current temperatures on the chart as well. But in 2007, 2008, there was a moderately strong La Nina, which is a cooler than normal sea surface temperature event combined with very low solar activity, the storms on the sun, all those cool pictures you see of the flares popping out and stuff. Those
Which is
do have
awesome.
Impact. Yeah, they're very wicked looking. I love that intro at Voyager where it flies underneath one. And then it resulted in a period of global cooling and record snowfalls across many parts of the northern U.S., Europe, Asia, and the former Soviet Union. The same type of situation, perhaps more severe, could occur again in the early 2020s, especially if we see a strong La Nina combined with low solar activity, which we are starting to go into solar null
Right.
period. Climate scientists are not completely certain why ocean waters suddenly warm up and cool down over a period of months or years. The warming of sea surface temperatures may be due, at least in part, to increased underwater volcanic activity. Researchers are constantly finding new active underwater volcanoes and thermal vents that may be contributing to the water temperatures. Recently, scientists discovered at least 3 to 6 times more heat spewing thermal vents along the seafloors where tectonic plates were pulling apart. In 2003, at least 9 hydrothermal vents along the Gackel Ridge in the Arctic Ocean were found. Arctic ice has been melting at a steady pace in recent years and may be due to the warmer than normal ocean waters. In April of 2015, an underwater volcano known as the Axial Seamount, about 300 miles off the coast of Oregon, erupted for a month and added 88 billion gallons of molten rock to the ocean floor.
That's
That
almost
number
as much
staggered me when I
water.
read it.
That's almost as much water that came out of the pipe over that weekend here.
Yeah. But 88 billion gallons of molten rock. That is nuts.
Insane. Yeah. Now, since the 1950s, data suggests that ocean temperatures have been getting warmer. According to research at the University of Alabama in 2013, take it with a grain of salt, climate models indicate a, quote, natural shift to stronger warm El Nino events in the Pacific Ocean might be responsible for a substantial portion of the global warming recorded during the past 50 years, end quote. Now, by contrast to the Arctic ice melt, glaciers have been thickening in Antarctica's eastern interior. That portion of the continent was experiencing increased snowfall and had a gain of about 100 billion tons of ice per year from 1991 to 2008. So, I mean,
I did not know that before I started researching this.
yeah, that
I've always heard the
is
melting. I never heard that was going on down there. It's like, holy shit, that's a lot of
that's a
ice.
lot of ice. Now, I mean, in contrast, in a month, now that's 100 million tons of ice per year. Now, to put that in perspective, when he was talking about the molten rock, that was a month, and it added 88 billion gallons of molten rock in 1 month. Now, from the late 40s through the early 70s, a climate research organization called the Weather Science Foundation of Crystal Lake, Illinois, determined that the planet's warm, cold, wet, and dry periods were the result of alternating short-term and long-term climatic cycles. Now, much of this data was based upon thousands of hours of research done by Dr. Raymond H. Wheeler and his associates during the 30s and 40s at the University of Kansas. Dr. Wheeler was well known for his discovery of various climate cycles, including his highly regarded 510-year drought clock that he detailed at the end of the Dust Bowl era in the late 1930s.
Yeah, I've funny enough caught the tail end of a biography or something on Netflix where there's actually a vault they've got that has thousands of different cores. Like they actually established an organization to go out and just drill cores on boats in various parts of the world and just send them back to this one place for analysis whenever. And they have a ridiculous amount of data there that they're still going through. They've only gone through like half. Really cool thing I might look into later. Now, one of the most recent cold periods was the Little Ice Age, a 500-year plus span that extended from the early 1300s to the mid 1800s. During that time, there was little solar activity or solar storms, which scientists refer to as the Maunder minimum. There were also numerous volcanic eruptions in the 1800s, like Krakatoa and Mount Tambora. In 1815, Mount Tambora had a major eruption, which was the largest recorded in human history, or largest recorded one in human history. Yeah, sorry. I don't know what the hell happened there. The explosion sent thousands of tons of ash and dust in the atmosphere, resulting in the lowering of the Earth's temperature by several degrees in numerous extremes. The event also led to the year without a summer in 1816 across parts of Northern Europe and the US, as snow was reported every month of the year, including the summer. During the early 1970s, our planet was in the midst of a colder and drier weather cycle that led to concerns of another little ice age. Inflationary recessions and oil shortages led to rationing, long gas lines at service stations nationwide or worldwide. And since that time, global temperatures have steadily climbed to the levels they are at today. But there were several interruptions of this global warming cycle. In June 1991, Mount Pinatubo erupted in the Philippines, leading to a temporary drop of 1 degree in the Earth's average temperature. And then in the late 2000s, a strong La Nina and very low solar activity helped send the planet's average temperatures back down to the 20th century average of 57 degrees before rebounding back to the early 2010s. And one thing too I wanted to note, because I forgot about it until that section, this warming chart that we've supposedly got up.
It was up, but we.
Let's bring up the chart again, because these spikes and dips, I don't know that people realize that center line is 57 degrees Fahrenheit. The top of the 2016 one on the far right is 58.69. So these spikes and drops are 1 to 2 degree variances. These are not like holy shit hot, holy shit cold. This is just a roughly 2 degree difference from the hottest it's ever been to the
It's like if you were to look at a sound file, and zoom in on it really, really close to see the minute changes. Is essentially what we're looking at with this graph.
The coldest it ever was, barring the actual ice age, was 54 degrees on average. The hottest it's ever been is 58 degrees on average. So we are dealing with spikes and drops, but it's not like 30, 40 degrees like some would have you believe.
Good to know. So moving on, the Weather Science Foundation also predicted, based on these various climate cycles, that our planet would turn much warmer and wetter, but giggity, by the early 2000s, resulting in general global prosperity. They also said that we'd be seeing widespread weather extremes. There's little doubt that most of their early predictions did come true. Now, in 2016 alone, data from the NOAA shows that over 200,000 heat, cold, and precipitation records were broken across the globe. Nearly 60% of the records were warm, about 28% were precipitation and snow, and the rest were cold. However, in early 2017, Some of the coldest weather in recorded history was seen across the northern U.S., Europe, Asia, and Siberia, and Russia, where one station in early January 2017 went to negative 81 degrees Fahrenheit. That is cold.
Yeah.
Now, to put this in perspective, too, this year, since we're going with that, with the wind chill alone here in Wisconsin, it hit, I think it was like negative 50 plus degrees. I think it was like negative 54, negative 55 or something, like, with wind chills. So that is pretty insane for this location. Now, Dr. Wheeler also discovered that approximately every 102 years, a much warmer and drier climatic cycle affects our planet. The last such warm and dry peak occurred in 1936 at the end of the infamous Dust Bowl period. Now, during that time, extreme heat and dryness combined with a multitude of problems during the Great Depression made living conditions practically intolerable. Now, for those of you who aren't familiar, I did have a chance, because I think the Dust Bowl was like what the kind of more central U.S., I believe it was, like Oklahoma, those areas.
Yeah, the breadbasket where all the crops are being grown.
Now, a lot of what happened there was, well, one, due to the dryness and everything else, and then how they were tilling fields and how they were doing crops and everything else definitely kind of gave way to that. We found better ways of how to deal with crops for stronger soil where that doesn't become a problem.
Yeah, rotating them, that way you don't suck up all the nutrients.
Because it really was serious, and it was to the point, I watched some movies and videos and documentaries about this, and it was insane what they went through. I mean, it was to the point where even if they were to put like wet towels or something like that at every loose entry into the house or anything else like that, I mean, you would have thick layers of dust inside your home. You had to have something covering your face to do anything at that point in time. It would cause respiratory issues, among other things. I mean, a lot of people died. A lot of people went hungry. It was a pretty damn terrible time.
Yeah, fun fact, they actually, for the movie Interstellar, they mixed in interviews of people during the actual Dust Bowl as part of the people talking in the movie about how the crops in that movie were dying. And they took a lot of inspiration from the Dust Bowl for the events that led them to leave Earth to try to find something.
I did not know that.
Yeah. So, assuming we get a new and very strong, cooler La Nina sea surface temperature pattern along with low solar activity that we're expecting, we may see a brief cool down of the Earth's temperature around the early 2020s. The next warm, dry climatic phase is scheduled to arrive early in the 2030s, probably peaking around 2038. It's quite possible we could see an average global temperature near 60 degrees, assuming there isn't a major volcanic eruption to disrupt the cycle. Based on current data, this new warmer cycle would produce even hotter and drier weather patterns than we saw during the late 1990s and early 2000s. We also believe that our prolonged cycle of wide weather extremes, the worst in at least 1,000 years, will continue and perhaps become more severe in years to come. We should remember that the Earth's coldest periods have usually been followed by excessive warmth. Such was the case when our planet moved from the medieval warm period from 900 to 1300 AD to the sudden little ice age, which peaked in the 17th century. Since 2500 BC, there have been at least 78 major climate changes worldwide, including two major climate changes in just the past 40 years. In terms of upcoming cooling and warming periods, only time will tell.
Now we get to move on to the fun part. Climate deniers. Denial. This isn't happening. None of this is real. None of this is real.
Freudian slip.
Right? Hello. Now, from reviewing various sources, there's not a list per se of criteria, but there does seem to be a trend in the denouncement of deniers. You're currently labeled a climate change denier if you do not believe in all of the following four conditions. 1, Earth is warming. 2, humans are primary cause. 3, this will have catastrophic results. And 4, only the U.S. government or some international governing entity can fix it. Well, I guess that would make me a climate denier then. Because the government is incapable of doing anything correctly or in a timely manner.
They couldn't make me a ham sandwich.
Yeah, so this breakdown can obviously, like I just pointed out, be problematic because while warming is a part of climate change, hot and cold fluctuations are both involved, which is why many arguing for climate change have largely dropped the global warming mantra. Yes, the government still sucks at everything, IKEA, 100%.
They do. Thank you, government employee.
Yeah, right.
And while there is evidence for both sides of what the primary driver of climate change is, I can see where people are not convinced that either side has definitive proof that would put the issue to rest. Another large problem for many is the repeated, the world will be unlivable in 20 blank blank. if you're not aware of how many of these there have been, we have had declarations in 1982, 1989, 2006, 2007, 2009, and 2012, which all stated that by today we would be past the tipping point. It would be too late. The world would be unlivable. I still see a working planet. We're still here. This has not obviously come true. Now, this moving of the goalposts really gives a lot of people a cold wolf type of disbelief that the next deadlines that now apparently in either 2030 or 2036, which ironically matches with the weather prediction that by the
Right.
2030 or so it's going to be more extreme. That's going to be the new deadline, the last chance to save our planet now. And then, of course, the last point is problematic because government approval is very low.
You don't
And
say.
well, yeah, and while Trump has an approval rating of around 46%, which is lowish but normal for presidents, Congress is at an all-time low of 18%. That if I got an 18% on a test, wow, there'd be problems.
Yeah.
So the U.S. government can't really control what other governments do, outside of maybe going through the UN, but they can only attempt to address issues via resolutions. But as we have seen with Iran, North Korea, and other countries, these resolutions don't always spur action. And that last point alone can label a person a denier, even if they do believe everything else. So, yeah, it's a hot mess.
It is a hot mess. So, in closing, some fear climate change, some deny it's real, and some don't know what or whom to believe, which makes sense going over all this. Many don't want to talk about climate change at all. Others say we must talk. And I hope, at least with this podcast, we've presented a fair look at both sides of this discussion and covered enough information so that everyone can understand the issue more coherently and why it is so controversial. It's simplistic to divide people into only two opposing camps of climate change, believers or deniers. The way we've been communicating the science of climate change has not been persuasive. For many, climate facts are not convincing, nor do they speak for themselves. And because people are not necessarily swayed by climate change facts, but rather the communicator of facts, the nature of communication, their personal affiliations and networks, and their personal experience, labeling someone who is confused by climate change as a denier does not advance us to a world of collective effort to confront climate change at all. So, I mean, again, there's so many different ways of looking at things and who you're getting the information from, who's giving the... It just makes it confusing, and then suddenly you're put with this label of you don't believe in climate change. That definitely makes things a little complicated. And I'm actually going to get some comments here top before we get to the end here. Bogus said, I don't think there is a deadline to it. I think climate change is going to affect things like insects, which will then equate to low crop yields and stuff like that. So rather than the climate change directly affecting the downfall of humanity, which makes sense, he said, hey, I came late like normal. Giggity. IKEA. IKEA said we have two major parties, the right side and the wrong side. If you don't agree with me, you are evil. That's
really one of the biggest problems. The fact that climate change has become political football. Thank you, Al fucking Gore, who ironically made a shit ton of money off
Al
of this
Gore.
movie. Made the
Al Gore.
That Gore. Dude. Oh. He's like the anti-vaccine champion of the fucking climate change.
I know.
But the fact that everyone's just like, we're right, you're wrong, fuck everything else, is really harming any actual attempt to figure out what can we do better as a species. Because I can tell you right now, cars aren't going anywhere for a long time. Air travel's not going anywhere for a long time. Cows and their farts aren't going anywhere because I like steak. Fuck you.
Neither are Top's farts going anywhere. Let me tell you, those are lethal.
Yeah. And, it's not freezing or heating any more outside of my house than it is inside my house. So
I don't know about that. I felt some skin peeling, sir.
Yeah, we need more talk about climate change rather than just screaming at people on what they should do because of climate change. And one of the biggest dangers of looking at data like this can be falling to the trap of correlation versus causation. Correlation is how close two sets of data are, and causation is a way to describe how differing events relate to one another. So, a great example of this I've found while researching this is that there is a 100% perfect correlation between the amount of ice cream that is consumed and the amount of shark attacks that occur. Now, I could sit here and eat a bowl of ice cream and I will not be magically attacked by a shark that jumps out of the sofa. But there is a third variable, hot temperatures. When it gets hotter, people want to eat more ice cream, and when it gets hotter, people want to go swimming to cool off.
Exactly.
Go swimming to cool off, there are sharks in the ocean. So you can't just sit here and say to me, CO2 is going up, therefore it's getting hotter, without doing more checking into the entirety of everything and showing me, okay, there is no other third or fourth or fifth thing going on. You have to be very careful to fall into a trap of, I found it, and then stop looking. That's not how things work.
Apparently, Grizzly would punch a shark in the face while eating his ice cream, I imagine.
Well, I'm sure they're looking for extras for the next Sharknado, so
Yeah,
there's always a possibility of that. Which is a great shitty movie, by the way.
Yes.
So we're really not doing a very good job communicating climate change, and maybe we can do a better job if we... Oh, there he is, Weem, finally. It's about that time. But maybe we can do a better job if we recognize that people are not just passive receivers of climate change facts, but actors with their own history, knowledge, and their interpretations of how climate change fits in their own view.
So with that, it is that time of the day. Unfortunately, this one has been a short one, a little bit shorter than our usual ones, but there is currently an active poll going on for the next. Man, I am
stroke.
It's been a long.
We got to do a podcast on strokes.
Seriously, I want to point out though, it has been an extremely long weekend. A very long weekend. Wife was in a car accident, broken bones. It's been a nightmare. So I've been running ragged. Anyways, I want to thank everyone for joining. And again, don't forget to check out the Discord server. Top, I'm going to let you handle that. Make sure to vote on the next topic. Also, please do comment on any topics you may wish to see, but do not appear on the poll yet. We do love getting input from everyone, and we've gotten some amazing input from people so far, and a lot of great topics coming up. Boyga, she is healing up. It's a slow process, but it is definitely happening, so I appreciate the well wishes with that. Anyways, with that being said, I want to say good night and thank you to everyone. Mira, oh no, Mira, you came in at yes. You missed it. You missed it. Ah, no.
But we do have an announcement for folks regarding people who come into the last second of the podcast. There's now going to be an easier way to watch a missed podcast.
Yes, we're going to be throwing these up on YouTube here shortly on my channel. You can check that out, youtube.com/Twistedtek. Make sure and check that out. All the videos from here on out are going to start going over there within a week. It's being recorded directly to my computer, so that way they don't get deleted from Twitch. So those will be appearing up there. So make sure you check them out. Give it some love over there. All good, Mira. I appreciate you at least showing up. The support's always great. Even Weem, when he's late. He's been here 20 minutes.
He's been lurking.
He has been lurking. Lurker. Anyways, I want to say thanks again for everybody showing up today. And as always, we appreciate the support. And we look forward to seeing you next Sunday for our next What Do We Know podcast segment. Top, you know the drill.
Bye, Top.